Hello, I'm Nichifei. I'm very glad to introduce HomoPAI to you. Homo means homomorphic encryption. PI means platform of artificial intelligence. HomoPAI means a secure collective machine learning platform based on homomorphic encryption. The work was done at Alibaba Group. So why do we create such a program? Firstly, nowadays data security is very important. So how can we achieve a platform that provides privacy-preserving machine learning? What's more, most of the related works on homomorphic encryption focus on the all sources scenario, where all data comes from a single data owner. In reality, it's more economically viable that multi-data owner would like to join that data to train a better machine learning project. Next, we show some background of our program. The first is the logistic regression. We use logistic regression to show machine learning on homomorphic encryption. In logistic regression, let F denotes the number of features, omega denotes the weight vector, X denotes the input feature vector. The property of dichotomous prediction of tagger Y is as the right formula. Our training algorithm is based on gradient descent, and the gradient is that this function is as following formula. We use the polynomials to approximate sigmoid function. Next, we introduce some basic operation of homomorphic encryption. Key generate public key and private key based on security parameters. Pack assemble a certain number of plain class into a polynomial. Unpack the reverse option of pack encryption. Use public key to encrypt packet data. Decryption. Use private key to decrypt ciphertext. There are many more homomorphic encryption operates like add, multiply, multiplication, rotate. So we introduce logistic regression based on homomorphic encryption. The most important part is data fragment. We need to pack data into a vector. For example, we have n multiply f matrix. We need to divide it into m multiply g submatrix. So we have less more matrix of ciphertext. We can speed up our system. The two parties protocol suppose party A and party B each holds several features, while only one party has the label with loss of generality. Let it be. B first run key generate to generate the key pairs and encrypts its data using encrypted data and sends the public key to A. So party A uses the public key from B to run encrypted data to encrypt his data. Next, the cloud service provider can train the model on the encrypted data using two-party parallel logistic regression training. Party B gets the result and decrypts the encrypted weight vector and gets the machine learning model. This is the two algorithms. This is the architecture of HomoPAI. We can see from the figure, party B and party A use encrypted NPI models to encrypt their data, and the third party to train their data. Finally, party B gets the ciphertext and uses private keys to decrypt the data. The two-party framework of HomePAI has many features. For example, we need only to know the data flow and the function module. Users can just drag and drop the table and click the button to run the program. It's user friendly. Next, we need to speed up our system. We need to consider about parallel design. We use the MPI message passing interface to parallel matrix in a product example. The example is showing us the bottom right figure. Finally, we need to demo our system. Let's see how our system runs.
This video will present to you HomoPAI, a secure collaborative machine learning platform based on homomorphic encryption. HomoPAI is built on top of Pi, platform of artificial intelligence, a machine learning product on Alibaba public cloud. HomoPAI has a drag-and-drop user interface, easy to use for non-experts. We can configure table names for the data source modules. Drag to connect the data sources to encryption modules. Drag to connect the encrypted outputs to the training module. Now we successfully constructed a HomoPAI project. Please note, actually the modules are separately run by Alice and Bob, but we put them together here to give a better overview. This is the table containing the machine learning parameters, including learning rate, momentum, and block size. This is the table containing Bob's data. In this example, Bob has 7,000 rows of data with the label and 16 features. This is the table containing Alice's data. In this example, Alice has 7,000 rows and 16 features. This is the joint training module. The number of HomoPAI instances, CPU cores, and memories could be configured here. Now, let's start training. Step 1. Bob generates the key pair and encrypts his data in the module Bob Encrypt. Note again that this step is actually run in Bob's project and invisible to Alice. After encryption, Bob's data now looks like garbage. Then Bob can send it to Alice for training. Step 2. Alice encrypts her data in the module Alice Encrypt using Bob's public key, which was generated by Bob Encrypt. Step 3. Alice run the module two-party training using both parties' encrypted data. Thanks to homomorphic encryption, she can do it without knowing the private key. Step 4. Wait about 2 minutes, and we receive an encrypted logistic regression model which could be used for further prediction.
This is the experiments of our program. The datasets we use two datasets. The first one is UCI adult datasets. The next is optional regression of handwritten digital datasets. The environments and parameters are as following. We developed HomePAI in C++ code with Microsoft Seal. We conduct the experiments on MPI framework. Each machine is an Alibaba Group instance. We use the NGD with learning rate on different datasets. The moment is the same. And with the sum of matrix is 1024 multiply 16. The results are shown as the right table. We can see that it just cost 32 seconds to run and train our thousands data. So it's very quick. In a conclusion, our system can train a logistic regression module on millions of homomorphically encrypted data in less than 2 minutes. The system does not obtain a linear speedup with respect to the number of nodes, but the increase of training speed is prominent. Due to the previous loss of encrypted domain, the accuracy of HomePAI is slightly lower than its plain counterpart. exchange for strong security and privacy protection. And we need more work to do. For example, we need to increase the accuracy with more interaction with bootstrapping. And we need to implement more machine learning algorithms, even deep learning algorithm. But the progress is being made. Thank you for your watching.